Hello. Right, so you guys have just sat the end of year test. The answers are coming up. Should let you know before we get going that the class average was 55%, which is about what I'd expect. Tests are of little use by themselves. Well, the important part is whether you go on to learn from the mistakes you made in that test. I had many people last year in my GCSE class get to D's at the mock and the end of year test, and they went on to get A's, and that's because they took this part seriously and they actually wanted to know what they got wrong. I suggest you do the same. Okay, so question 1. Let's zoom in a little bit. Question 1, don't you hate when PowerPoint does that? Question 1, which of the following for which one of the following is a scriber used? Okay, so that guy there, he is a scriber. He is a sharp piece of carbon steel used for scratching metals, and therefore he's used for marking out. Which one of the following is most suitable for joining two pieces of pine together? Okay, this one a lot of people got wrong. Plain old PVA. You probably think of being like primary school glue, white glue, wood glue, quite cheap and cheerful, but it is the most suitable for joining two pieces of pine together. It's water soluble, it sinks into the wood, and it goes rock hard. It's so strong that it's stronger than the wood itself. So if it's going to crack after you've glued it, the wood splits around it. The glue is as strong as you need it to be. Only used for indoors, it's worth saying. These three glues, epoxy resin, contact adhesive, they can be much more expensive. They can stink to high heaven. They're spirit based. They've got lots of warnings all over them. So lots of people thought that because of those reasons they're going to be stronger, but it's not true. PVA takes ages to dry, but when it does dry, it is the boy for the job. Okay, which of the following is a wasting process? Obviously, a wasting process is a process that creates waste. So you start off a big block of something, and then you waste it away until it ends up looking like the thing you want it to look like. So whether you saw something off or you drill holes, you're creating waste in the process of making your product. So turning, either you turn a piece of wood in a wood lathe, or you turn a piece of metal in a center lathe. As you're turning it, you are removing material and creating waste to make your product. Vacuum forming, you take a sheet and there is no waste involved. You just suck it onto a mold, but there's no waste. Casting, you take metal, you liquefy it and you put it into a mold. There's very little waste. Blow molding is the opposite of vacuum forming, really. Again, no waste. Turning is a wasting process. Alloys. Alloys obviously are a mixture of metals. Not necessarily metals, could be a mixture of different materials, but commonly thought of as a mixture of metals. Copper, zinc and aluminium you will see in your periodic tables. They are elements. There is nothing added to copper to make it copper. It is just copper. The same for zinc, the same for aluminium. Brass, however, is a mixture of copper and zinc together. And it has good corrosion resistant properties like copper, and it's quite hard. That's why you can hit a cymbal and it doesn't deform, but nonetheless brass is a mixture of copper and zinc, is an alloy. Which one of the following processes is most suitable for producing long lengths of plastic guttering? The answer is extrusion. These are some metal, some aluminium extrusions. You'll notice the profile on as a sort of cut through profile is the same along the length. So whatever shape you see at the top is the same shape it will be right down the length. Plastic guttering is another example of extrusion. Plywood. Plywood, you're always going to have the front and back, you're going to have the grain going the same directions, and the thinnest piece of plywood you can get is with one other piece of wood in the middle with the grains going the other direction, so it's nice and stiff. So therefore the smallest, the thinnest plywood is a 3-ply plywood. That is an odd number. The next one up is a 5, the next one up is a 7, the next one up is a 9, etc. The one here it's true is it has an odd number of layers.
Keep your eye on it.
Okay, that was my mistake. Ignore that. Which of the following is a thermosetting plastic? So the ones that when they heat up they get soft, acrylic, polythene and PVC are all thermoplastics. The only one you need to know about in your entire syllabus is UF. You will never need to spell this, do not panic. You may need to say UF, i.e. what would you use for a light socket. You would say I want to use UF because it's really hard and it has a very high melting point. Something like that would be good. Its proper name is urea formaldehyde. It's the only thermosetting plastic you need to know about, so learn this and you will not go too far wrong.
And my new band is called Siskill.
A few people got this one wrong. A screw thread is described as an M6 by 1. The M part means metric, so it's not the old imperial style threads where you have a 3/4 inch thread. It's metric, so you know that 6 is going to be 6 millimeters. The M means metric. The 1 is how far apart. Watch the cursor here. How far apart the threads are. So this distance between those threads is 1 millimeter. More on that later. And 10. Tempering. Loads of you got this wrong. Tempering. Let's say, well, first the hardening part, what you've all done, is when you take a carbon steel, you heat it up and you quench it, and that makes it go rock hard. It's called through hardening because it goes hard throughout the entire piece. It makes it really brittle though, so it's hard in that it doesn't scratch. Great for things like our scriber we saw earlier, but it would be very brittle and it'd snap. What you need to do after that is you need to temper it, where you heat it up to an exact temperature, and that removes the brittleness from the metal. Moving on. When you pull something apart, you are putting it in tension. You are putting a tensile force on it. When you are crushing things together, crushing is compression. When those two forces, the thing is in there and it's getting crushed, it's getting compressed. Okay, moving swiftly on, we're halfway through. What you will see this kind of layout in any test you do for this example. You need to know that when you describe what it's used for, you need to say cutting a thread, for example. It's a die that is used to cut a thread on a rod. I'd accept that. But you also need to be obvious. I know a lot of you think it's too obvious to mention, but you need to say in metal. So you don't use this to cut a thread in wood. You use to cut a thread in metal. Sounds obvious. I know you all know that. You've all done that, but you need to say, is it wood or is it metal in all cases? So the next one, hacksaw. And that's for hacking through metal. So cutting metal to get 1 mark. You'll notice these tiny little teeth on saws that work with metal. That is a bit of a giveaway, but this one's always quite easy to confuse with a coping saw. You just need to learn the difference, and we will do. I would accept knockdown fitting on this one. Joining flat sheets of material together to make furniture is their definition. I like to say it makes it easy to assemble, and you can use commonly available things like screwdrivers to assemble furniture. So you don't need to be a carpenter. You can just use these things, and now suddenly everyone can make furniture in their own homes just using a screwdriver. Okay, and this one is a micrometer. Remember, a gas meter is something that measures the gas in your home. So meter, like a thermometer, is a thermometer used to measure the heat. Thermo. A micrometer measures very accurate measurements. Okay, the next one. What is the advantage of batch production. Well, that was my question, and I think that's a bit of a dodgy question. What I should have said is what the advantage of batch production compared to one-off manufacture or compared to mass. The way I worded it made this very difficult. So answers you may have mentioned. Batch production makes products more quickly and cheaply, but that's meaningless. Than what? So than one-off manufacture. How does it do that? Well, batch production, when I say batch production, you've got to think, right, he wants me to say here jigs. The examiner wants me to say templates. Okay, always think jigs, templates when you say batch. Jigs, templates, and flexible machinery. What I mean here is a pillar drill is often used in batch production, for example. It can be used to make anything that's currently being made by that company. When we stop making that product, we can use a pillar drill to make the next product. Okay, so it doesn't mean you've got to invest a fortune in really specialist tools. We use commonly available tools like a wood lathe, maybe, like a bandsaw, like a pillar drill, like a belt sander, all those things. It's flexible in that we can use it to make the next thing. But it's much more flexible than mass production and needs less investment in expensive machines. My question, bit of a dodgy one. I was looking for you to say two things for 2 marks. Name a mass production process. Right, so that is things. We're talking now 100,000 items being made by processes that can be really quick. So plastic injection molding is a great example of mass production process. Blow molding, i.e. milk bottles, 10,000 per hour are made with blow molding. That is a mass production process. Punching, you can stamp out hundreds of holes simultaneously, and as the metal just whizzes through, you can just punch out shapes, you can punch out holes, you can stamp shapes into metal like a car body. You just stamp it into the shape of the bonnet, and then you also punch the holes where they need to be. Very accurate, very high volume mass production process. Vacuum forming, again, like plastic egg cartons, those little plastic disposable cups, that's all made by vacuum forming. Again, you'd do about 100 would be sucked onto 100 molds simultaneously, very quickly.